Okay, so one last issue we want to cover here with regards to naming. But before I get into this, couple of things I want to point out. One, I failed to mention in the last video where it would have been a little more relevant, and then one thing that we're not going to cover that I want to describe. I said aluminum is generally only going to have a charge of +3 when it's in an ionic compound. The same is true for zinc, except zinc is almost always +2, and silver here is almost always +1. Now, I find it's kind of easy to remember that if you see a periodic table because of the diagonal relationship between them. And aluminum as an ion is really only stable as +3, zinc's really only stable as +2, silver's really only stable as +1. Now, because of where aluminum is, it's never called aluminum 3, it's always just aluminum, and you know it's +3. It's very common to do the same thing for zinc and silver. So in an ionic compound, you usually don't say zinc 2, you just say zinc. You don't say silver 1, you just say silver. So you may see some examples where you're thinking, oh, why isn't the silver +1? It probably is. It just doesn't carry the +1 in the name, since +1 is really the only stable charge that silver takes on. And hey, there's some variation from book to book. Like, I think it's less important to memorize issues like that than it is to be able to apply the naming rules. So I will often write silver 1 in a key, but you don't have to put the 1 there if it is silver. Okay, the other thing I wanted to mention, there's a section in chapter 2 about naming acids. We are not going to cover that in Chem 151. I find that just gets a little too confusing with all the naming we're doing, and it's a little more appropriate to talk about naming acids when we get to the chapter that goes into more detail on acids, which is in the second semester of the class. So we'll come back to naming acids if you stick with chemistry and come back for Chem 2. Okay, the last thing we want to talk about are a separate type of compounds called molecular compounds. So ionic compounds are held together by the charge difference between the cations and the anions, right? So there's like an electrostatic attraction there between charges. There's another type of interaction that can hold atoms together in a molecule, which is called a covalent bond, and that's based on atoms sharing the electrons together. So molecular compounds, or compounds held together by covalent bonds, sometimes also called covalent compounds, these are all formed by just nonmetals. So formed from nonmetals. So if you see a compound and all of the components are nonmetals, you're going to use this naming system that's based on describing how many are present in the compound, as opposed to the system we've developed for naming ionic compounds, right? So just as an example, right, if we're looking at nonmetals, say carbon and oxygen, there are several different ways that carbon and oxygen can bond together, where we get different numbers of carbon and oxygen. Now, since carbon is not a metal, we don't want to describe it as having different levels of positive charge. So one carbon, one oxygen needs to have a different name from one carbon and two oxygens. So what we do is we use prefixes to describe the different numbers. So looking down toward the bottom of the page here, we use 1 to describe 1, we use the prefix mono. To describe 2, we use the prefix di. Now, we usually don't use mono on the first atom in the formula. So CO is carbon monoxide. So we're combining mono and oxide, and then we're just dropping one of the O's, so we don't have two O's in a row. CO2 is carbon dioxide. One carbon and two oxygens. Okay? And because of this sharing interaction, there's a lot more complexity in the way that atoms can connect. So we'll get lots and lots of variability in the types of compounds that we see. And as a result, the only way to name them consistently is to just describe how many atoms are present. And I'll show another example where we see that there's a lot more going on than just, is there one or two oxygens? Now, even simpler to name are diatomic molecules. So there are There are 7 compounds that exist just as diatomic molecules. They are hydrogen, nitrogen, oxygen, and then the halogens, fluorine, chlorine, bromine, and iodine or iodine. Any diatomic molecule where there's just 2 of one particular atom, the name of that molecule is the same as the name of the element. So H2 is commonly referred to as hydrogen, N2 as nitrogen, O2 as oxygen, etc. Okay? Now, applying the names here, so I have written out all the prefixes here, and as an example, let's imagine we're combining nitrogen and oxygen, and there are probably tens of possibilities for nitrogen and oxygen. And I'm just going to list out a few of them just to show how we can use these prefixes to name these types of compounds. So there's 5 of them, right? So we certainly don't want to just say, this is nitrogen and oxygen. So what we do is we use these prefixes to just describe how many nitrogens are there, how many oxygens are there. Now, the ending still gets changed to IDE, just like we saw in the ionic compounds. So these all will end with oxygen. We'll change all of that to oxide. So 1 nitrogen would be, we would say nitrogen. Again, we don't need the mono for the first atom in the formula if it's only 1, but just 1 oxygen as the second atom in the formula needs mono. So this first compound would be nitrogen monoxide. Again, we're dropping the extra O when it's monoxide, and we'd have 2 O's next to each other. We drop 1. 1 nitrogen and then 2 oxygens. That would be nitrogen dioxide. But 2 nitrogens, then 1 oxygen. That means we'd need the di in front of nitrogen. So that would be dinitrogen monoxide. 2 nitrogens, 4 oxygens would be dinitrogen tetra, right? And we'd have an A next to an O if we put tetra in there, so that's tetroxide. We drop the A so that it doesn't give us a kind of diphthong in there of 2 vowels next to each other that might be hard to pronounce. N2O5 would be dinitrogen pentoxide. Okay. Now the only time we don't drop that extra vowel is if it's an I. So if there's 2 dioxide, we keep the I because I and then O break cleanly into 2 syllables in a way that 2 O's together generally don't. Okay, a couple more examples here, right? I think you do have to learn the prefixes, mono, di, tri. Tetra is the one that usually confuses people. Right? A lot of people want to go to quad for 4, but that's not how it goes. But penta, hexa, hepta, octa, nona, deca for 5 through 10. I think most people are fairly familiar with those from geometry and different polygons that you may have encountered. So let's just look at a couple other ones. CCl4, right, would be 1 carbon and 4 chlorines, so that would be carbon tetrachloride. Okay. Let's see. NBr3, it would be 1 nitrogen and 3 bromines, so that would be nitrogen tribromide. Okay. Now, the tricky part about this is when they get mixed in with the ionic compound. So just be careful about that. You may want to just verify first, am I looking at a metal and a non-metal, which you would want to name as an ionic compound, which means no prefixes, or is it all non-metals? Because in that case, I'm going to name it with the prefixes, right? And be careful of ions as well, because if you see an ion, those have their own names. So NO2 is nitrogen dioxide, but NO2 minus is a polyatomic ion, so that's nitrite, right? That shouldn't be named nitrogen dioxide because it has its own name. Okay, that is the end of chapter 2. So we'll return with another video for chapter 3 soon.